everyone. Welcome to Expert Talks Online. My name is Lindsay. I'm a delivery lead at Equal Experts, and I'll be your host this evening. This evening's talk is going to continue our summer series that covers quite a diverse range of topics. We've gone from blockchain to security to digital transformation. And tonight, we're going to be exploring how software development practices such as test-driven development and build pipelines can be applied to infrastructure as code. And we're very excited and very grateful to have John Barber presenting this evening. Following his talk, which will be about 30 minutes long, you'll be joined by a panel that consists of Ali, Paul and Duarte for Fishbowl Discussion. During the Fishbowl, we'll be using Zoom's Q&A function to ask questions. So if you've got questions either on your mind now or that come up during the talk, please feel free to start adding them into the Q&A section. And then they can be voted on. We'll be covering the top voted questions first. During the Fishbowl, if you'd like to join the panel and help answer some of the questions yourselves, then please use the Zoom raise hand function and we'll add you to the panel. Okay, that's enough talking for me. I'll now hand over to John to introduce himself and kick off his talk. So over to you, John.
Thanks, Lindsay. I'll just start sharing my desktop. Yes, so my name's John Barber. I've been a developer my background's in software development. I've been a developer for 20 odd years. More recently, I've spent quite a bit of time in the oh, sorry. I beg your pardon. That's great. I've been spending quite a bit of time in the platform engineering space, and so this is a topic that's very close to my heart about how do we apply software development practices to infrastructure as code. So one of the reasons I enjoy the platform engineering space is that it's a very rapidly evolving space. It's as I'm sure you all are all aware, it's hugely popular, and it's become a key part of what we do in the cloud native era or in cloud computing. And one of the reasons I enjoy it is it's the closest I think you can come to being the much maligned phrase a 10 times developer. Often one of the best definitions I've seen of that is to be a 10 times developer, you find 10 developers and make them twice as good as they currently are. And by doing infrastructure and platform, that's certainly the case. You can enable an awful lot of people. You can make things an awful lot better for a lot of people quite quickly. But conversely, that also means you can also make things not so good for people quite powerfully. So that's some of the pros and cons to this particular practice. So it is a very rapidly evolving area. There's also the problem with this is there's lots of noise, there's lots of hype, and knowing what's important isn't obvious, and it can be hard to work out what is important and what's not so important. So we can apply the techniques that emerge from software development, but the differences between infrastructure and code as traditional software development mean you have to make adaptations. Now, it's important to be mindful about these because a lot of the techniques that have emerged from software development are the more valuable ones, I would personally argue, are the ones that take into account human nature. So we'll go into this a bit further on when we get into some of the TDD stuff. But the tricky thing about this is the benefit that these techniques we get from software development aren't always immediately obvious. So you have to be a little bit careful about what you choose to use and what you choose not to use. Similarly, trying to apply the techniques from software development as is without taking into account the differences will be frustrating and could even lead to you abandoning them altogether. And that would be a huge pity, as I've just been saying. And especially if this is an area that you're new to, if you're say from a a traditional ops background, moving into infrastructure as code and trying to understand what those practices are, you could just give up on the whole thing. And similarly, if you're from a background of being a software developer and moving into infrastructure and code and trying to apply the lessons we've learned from that, that can also be extremely frustrating, and I think will be quite a hard lesson to take on board. So the two key differences I'd like to cover today, or which are going to influence today, are the first one is time. So it's so much longer to see the effect of a change on infrastructure than it is when we're doing software development. So whether you're doing Terraform to provision some stuff in Amazon, or you're doing something in a Kubernetes cluster, it's going to be quite a lot longer for your change to take effect than it would be doing traditional software development. One of the impacts from this, there are many, but one of the big ones, for example, is paying attention to diagnostics. So the fact that it takes so much longer to effect this change, and when there are problems, it can take a long time to recreate that, that particular effect. Making it clear around diagnostics, trying to help or make it clear what the problem is, becomes even more important. And we'll cover that in a bit later on. The second aspect is that the fact that we're one step removed. So the code that we write isn't the final artifact. So again, if it's Terraform, you produce a well-written Terraform module, but actually that in itself doesn't really add any value. The value you get from it is when it's actually applied. So when you provision your Amazon setup, for example, that's when you really start getting value back from what you've done. Unlike traditional software, where once you start running that software, in theory, you start getting the value more or less straight away. So both of these, and in fact everything, mean that fast feedback loops are more important than ever. And a note about the tools that we're going to see in a minute. The approaches we'll talk about don't rely on any particular tooling. So the tools I'm using are ones that I particularly like, I'm comfortable with, but there's nothing special about them. You can apply these principles to whatever tooling you happen to be using at the moment. So let's get on to talking about specific practices. So the first one I'd like to talk about is pipeline structure. So this is an example of a practice from software development where you don't need to modify it as such, it just becomes even more important than before. So it's kind of doubling down on the practices that we pull from that from software development. So for example, make sure we have distinct stages in the pipeline and focus on high value feedback as soon as possible. And by high value, by this I mean, for example, if there's a common error that you see a lot, you might want to move that as quickly as possible, or as early as possible in your pipeline. Group your tests by stage. We'll go into this in a minute, but just have an agreement with your team about the stages in your pipeline, what you're going to test in that pipeline, and the nature of the tests. So if I jump to an example pipeline. So what we're covering here, the example I have here, this by the way is in Concourse build server. And this is an example pipeline we have going on here. And this particular example is for a Helm chart for Kubernetes. And a quick explanation for people unfamiliar with Helm. Helm is a way of templating deployments into Kubernetes, and it allows you to parameterize them. It gives you more things as well, but what we're more concerned about in this particular example is a templating function, which will become clear in a minute. But generally speaking, this is a kind of like idealized pipeline structure. Another thing to note as well is that I possibly wouldn't have exactly this pipeline set up in production, but it's useful for our talk. So what we have at the very beginning is we have our inputs coming in, we assemble our chart together, and then what we next have is we have two jobs, what I've chosen to call fast tests and slow tests. Now what we mean by that is in traditional software development, in your fast tests, what you might mean by that is that you have an agreement that the tests in this stage, nothing will leave the address space of your software. So you might choose to mock out all of your dependencies, and you may even choose to not even touch the disk for the tests running in this particular stage. So they'll be extremely fast. They should run sub-second, so you get that nice fast feedback. Slow tests might be conversely, the agreement there is that you don't muck anything out. The slow test, you actually speak to something that looks like the real systems. So in the example we have here, or rather in this pipeline here, as I was saying before, with infrastructure as code, the feedback is so much slower, it makes this even more important. So it's not always possible, which you'll see in the next example, but what we have here for our Helm chart, what we've got going on in the fast tests, if I jump in, we're actually using here, the agreement here is that we won't actually speak to a real Kubernetes cluster. So we'll try and run everything we possibly can in isolation. So in this particular case, what we have in our fast tests, if I jump into this, we have two particular checks we do. So the first one is a very simple lint operation. And linting is now, as you can see there, we're just using the Helm lint command. And that can pick up an awful lot of problems, just for example, problems with the formatting of your templates and other metadata that might not be there. That's actually caught quite a few problems in the past on projects I've worked on. Then the next phase we go into here, well, actually, let me explain a little bit about what this chart actually does. So this chart, when it's deployed, this will actually use a fairly common approach in Kubernetes, where we want to protect resources in our cluster behind an OAuth 2 authentication flow. So typically, we've, for example, protected dashboards behind this, the idea being that you have to be, say, for example, in a particular GitHub team, and then you use the GitHub OAuth flow to authenticate yourself, and then you're granted access to protected resources. And we want to do this as a Helm chart because we actually want to maybe use this in front of quite a lot of things. In this particular chart, the most important thing about this is you have to wire together 3 entities correctly, and it's all fairly complicated. There's all kinds of configuration that needs to be connected between the entities that the Helm chart produces to make sure that it works. And if that configuration is incorrect, it can take quite a while to debug. You could spend hours actually in the cluster trying to work out what's not working. So this is a nice example of bringing this test forward. This is a high value test that we have going on here. So one of the tests we have actually makes sure that that wiring is in place. And that's it's nice to do it as fast as we possibly can, because if it gets to the point where we deploy this and it's not working, we can waste an awful lot of time looking into this. So the way we actually do this is we're using, let me jump to the code we have. We're using a testing library called Terraform, and this is written in the Go programming language. So this is our test here. So hopefully it's fairly self-explanatory. What we have, you might be familiar with the arrange, act, assert pattern of writing tests. So what we have going on here is, this is the arrange part. So what we're doing in the library itself is it's using the Helm template command. And what that does is that just basically generates the template and using values that we supply without speaking to the Kubernetes cluster at all. And we'll see in a minute that just produces a lot of YAML. This is where the template's actually rendered. And then the important thing is we then consume that YAML and we we verify it. And if we jump to the verify method, what we're doing here is we actually use the Kubernetes SDK in Go to consume that YAML, populate objects, and then we can interrogate the objects and make sure that they are as we need. So if we jump back to the top, if I quickly run this test now, so like I say, this is just running locally with no not speaking to any Kubernetes cluster. So you can see there, for example, that was 160 milliseconds. We can see the output here, and everything is looking good at the moment. So if we jump, if I make a change to introduce a deliberately breaking change, this is one of the templates we use, and you can see here, this is one of those crucially important wiring parts, and it would be very simple to fat finger this just by doing something like that, and then the template will render fine, as you'll see in a minute, but it would break the functionality. It just would not work. So if we run the tests again though, what we'll find is this will be picked up by our tests. So now you can see that's failing. And if we scroll to the bottom, there's lots of output. You'll have to take my word for it, but there's lots of valid YAML being printed out there. It's as far as Helm's concerned, all the output is correct, but our test here is catching that there's a problem. So that's extremely valuable. We catch that very early on in the process. So if I revert that change and we run the test again, there we go, and we see that time it took 60 milliseconds. So that's an example of a very nice fast test that we can run early in our pipeline. So if we jump out of that, that's an example of what we do in our fast tests. High value feedback very early on, and we haven't even got as far as a cluster yet. Then next we have slow tests. In this particular case, we don't have any slow tests. We don't speak to any Kubernetes clusters, but that's kind of like a placeholder to say the kind of things that you might put there. So that might be where you actually do deploy to a cluster, and you might do some functional testing, something that's more appropriate where you actually deploy for real and try it out. And finally, then we ship it. So that's an example of an idealized pipeline and the value of that practice. So the next aspect I'd like to talk about is, this is a particular practice from the software development world, where this isn't so much a case of doing more of the practice. This is more of a case where the practice is quite badly affected by, in this case, the time factor. So test-driven development is a practice from the XP world, and it's a very valuable practice. We'll go through that in a second, but the main impact of the slowness is the delayed feedback. And test-driven development is one of the practice I was talking about, one of the practices where it's not immediately obvious what the benefits are, but one of the benefits really is about it working well with humans, how we think, how we work. So let's go through that let's quickly jump to the diagram. So this is a diagram from a book, Growing Object-Oriented Software, by Steve Freeman and Nat Price. And this is the classic kind of, you may have heard referred to the red-green refactor loop. So the idea being here that when you're doing any piece of work, you always start with the failing test. So that's the first thing you write. That's this test is failing, hence you've got the red arrow. Then this is an extra one that they've added in the book, which I'm a big advocate of, which we touched on earlier, which is make the diagnostics clear. So when that test is failing, make the reason why that's failing clear. So that might be putting a message in the test. It might be even giving it the name of the test, but make it clear. Then the next part is to make the test pass. At this point, you can commit your code. Then you can move on to refactoring, because you've got a passing test now. And what that means is you have the confidence to refactor because you have tests from all your existing tests that allow you to refactor, and you can quickly run them and make sure you haven't broke anything in your refactoring. And then you can commit that and then back to writing a failing test. Now, the important thing about this is in these, as you're moving around this particular diagram, it allows you to focus on one thing at a time. So on a good day, when you're writing a failing test, you just need to worry about that. You can just write the failing test. You don't have to worry about making the test pass at that point. Write the failing test. Then you can concentrate on making the diagnostics clear. Then you can focus on making the test pass. And then you can focus on refactoring. So it's very much, it's keeping your mind on track on what you're doing. Now, what enables that is speed. If it's extremely fast from your IDE to just run all the tests or selection of tests you need to do, this makes it very easy to do, because if it takes a second or less to run the tests, moving around this circle is really easy. Unfortunately, with infrastructure as code, that often, well, that just isn't the case. So it's very hard to stick to this cycle, and it's a known practice from the lean circle or the lean thinking about transaction cost and batch sizes. The larger a transaction, the more expensive a transaction is, and in this case, the transaction is time, the more work you'll put into it. So as humans, because it can take a long time for our tests or our infrastructure's code to be applied, we're tempted to make more changes. And that can make it extremely hard to keep track of what's going on. It also leads to larger commits to our version control system. It just makes it, it's easy to lose discipline. So with that in mind, let's see what we can do about that. So if we look at our next pipeline, so this is a pipeline which kind of shows a worst case scenario for this. So for this one here, what we're doing is we're building an AMI image in Amazon using HashiCorp's Packer. This is a fairly common practice. What we have going from the left to the right is we have the build job where we build the AMI using Packer. Then we actually, then we to test it, we deploy for tests, and we deploy the AMI image using a chunk of Terraform. So we deploy our AMI, we set up some infrastructure as well around that AMI to let us test it, which is all around security groups and load balancers. Then we run our tests that use the output from the Terraform to actually get the parameters that they need, such as HTTP endpoints. And if those tests pass, then we publish the AMI simply by tagging it, and then we destroy the test environment. So if we look at how long this pipeline takes to run end from end, if we jump into the build phase, hopefully you can see here, the last time we ran this, the duration was 6 minutes, which is fairly typical for an AMI build. So you can see here, for example, we've got lots of things going on. So that's a 6-minute process there. The last one there took 7 minutes. So that's a long time. And if we jump back to the deploy phase, that takes a minute. That takes 53 seconds, similar kind of time. Jump to our tests, they take a minute as well. So you can see this is quite an expensive pipeline. So if when you're developing this locally, then that just isn't feasible. If you run that for each change, that's just not sustainable. So there are some approaches we can take to try and make this a little bit less painful. So if we jump to the test we use here. So what we have is this function here called test deploy and behavior. And again, this is in Go using the TerraTest library. And what we have, what we're using here is we're using test stages. And a test stage is a way of kind of sandboxing a particular stage of work. And what we have going on here, the defer keyword for those in Go, if you're not familiar, this is kind of like a cleanup. So these are all tear down actions after our test is finished. And you can see here, it's cleaning up the AMI, which in this case actually deletes the AMI from Amazon. Then we clean up Terraform, which means we tear down the test setup. And this also, this stage here, logs will actually get syslog entries from our system and dump them out to screen, which can be useful for debug purposes. So they're cleanup actions. Then kind of the first real action as part of the test setup is to actually build the AMI, which is the one we saw before, which is the 5-minute stage, deploy the Terraform, which is the 1-minute stage, and then we've got a chunk we've chosen to call validate. So the reason we're using test stages is these are actually, we can turn these on and off from the command line. So when you're working on this locally, what that means is if you're focusing on the validation, and the validation is where we're actually making sure that the behavior is as expected. So you can see here we've got, we're checking that HA proxy is running, which is something we've deployed in that AMI. We chunk these together in the validate stage, which means that if I jump to here, this is part of the test framework. This is the important part here. So you can see, for example, by using the way that the Terra test library works with test stages, is you can use set environment variables. So basically, if you prefix the stage name with skip, then it will not execute that stage. So you can see here, this particular invocation here, this will not build the AMI, it will not deploy the Terraform, and it won't delete the AMI. So this effectively is just running the verify stage. So if we jump back again, that means that while you're focusing on these, you can cut down on all that extraneous noise and just focus on the value that's going on here. It's a little bit clumsy, but it's faster than running the whole stage again. And this also is another interesting decision to take as well, is that you may also have heard a good practice is to do 1 assert per test. Now again, because of the expense of the arrange phase, which is creating the AMI, setting up the Terraform and everything, that it may not be viable. If we basically had the same test for each of these validations, then a full test run would take the best part of an hour. So what we have is we have multiple assertions, but what we've chosen to do is make them distinct, partly by having them as distinct method calls here. And also if we jump into this one here, for example, this is using subtests in Go. So you actually get in the output, you get them segmented. So this might be a little bit clearer if I jump to the pipeline. So if we jump to the test stage, scroll to the very bottom. So you can see, for example, we have these lines here, and you can see that particular one there is the verify that the SSM agent is running. And if this failed, the failure would say that it occurred here. So that helps drill down a little bit. It helps mitigate some of that practice of having multiple asserts for one test. Oops. And the final thing I'd like to quickly cover is drift detection. So this is part of the implication of the fact that the infrastructure as code that we write, be it Terraform or Helm or another thing, is of itself not the final artifact. We have to apply it to something to get the value from that. This means that the changes that we bring about can be undone by something else. So somebody could use the AWS console, the command line tools, whatever, to make a change to the thing that we created before. It's very hard to do this with traditional software. You'd have to go in, say if it's Java, and edit the class file using a bytecode editor or something like that. But it's very easy to do in the infrastructure as code world. So what we want to do is, when this happens, we want to detect this as fast as we possibly can so that we can reduce the mean time to recovery. Because the faster we can detect this has happened, the more chance we have of finding out what actually caused this change. If it takes days to find out that somebody went into the Amazon console and changed an S3 setting to make everything public, then we're going to struggle to find out why that happened and try and remedy that. So what this means, there's multiple approaches to this, but what we can do is we can use some of our tests for precisely this. This is often called synthetic transactions, synthetic monitoring. So we can use some of our tests and run them regularly through our systems to make sure those tests still pass. And in fact, what's taking that one step further, a very powerful technique is to consider adding tests such as that, and indeed alerts and monitoring to the definition of done. And put them, when you're starting on a new piece of work, put the alerts and monitoring in place first. Make sure they're read, make sure they're triggering, obviously not sending them to your real pages, but sending them somewhere. And that means that it's starting with a failing test. Your alerting and monitoring becomes your failing test. And then the definition of done is, you're finished when those alerts stop firing. And that will help with drift detection. So in summary, the main problems the big problem we have is that infrastructure as code feedback is often orders of magnitude slower than traditional software development. The implications of this are sometimes non-obvious, especially when it comes to the things that are mainly about working well with humans, about trying to make us focus well, all those lessons that have taken quite a while for us to learn in the software development world. Also, context is everything. Your context where you work is really important. Do what works for you. So there's lots of advice, opinions out there, especially when you're new to this, saying what you should be doing. These may not be appropriate. So work out what works for you, and always just keep on evaluating, seeing if they're working, seeing if they're not, and change course as you need to. I personally, or rather on quite a few of the projects I've worked on, the DORA 4 key metrics, we've got links in the resource slide, can help frame decisions for that, for example. But find some way that you can evaluate what's working for you and whether you need to reconsider what you're doing. And finally, as ever, fast feedback loops are key. They're the #1 way of trying to address all these problems. Finally, we have some resources, and we'll be publishing the slides so you can get some more links. And that's it. Thank you very much. So I'll hand over for the Fishbowl.
Great, thank you very much, John. That was a fascinating talk. We're going to move into a Fishbowl discussion now. We're very pleased to have on our panel John, of course, Duarte, Paul, and Ali. And I'll get them to introduce themselves in just a second. Just as a reminder to pose questions that the panel will discuss during the Fishbowl discussion, please use the Q&A widget. We've got some initial questions there. Please vote on questions that you would like answered, and then we'll work through them in order of highest votes. If you'd like to join the panel yourself and cover any of the questions, please use the raise hand feature and we'll add you to the panel. Okay, I'll hand over now to Duarte, Paul, and Ali to introduce themselves, and then we'll start covering questions. Duarte, want to kick off?
Yeah. So hi you all. So my name is Duarte. I'm a software developer in transition to platform engineer. So my last 2 gigs was as a platform engineer, but I'm on this transition from one position to another.
Great, thanks. Paul?
Hi, sorry, bumping the mute button there. Yes, I'm Paul. I'm an AE associate, and yeah, I've been working with infrastructure code tools for a few years now, CloudFormation and Terraform. I find them very much, as John's talked about, a blessing and a curse at times. So yeah, looking forward to these questions.
Great, thanks. Over to you, Ali.
Hi, I'm Ali Lotia. I'm the head of operability at Equal Experts, and yeah, I think like many of my colleagues, I've shared frustrations and joys of having using the tooling that we currently have in this space.
Great. Okay. Thank you, chaps. Right, we'll start tackling some of the questions now. So currently top voted question is from Adam Bennett, and he asks, what are your opinions on other development practices like reviews and versioning? Over to the panel.
Well, I can kick us off there, I guess. Certainly when it comes to versioning, I think that's crucially important. I think a lot of John's content kind of implied there was versioning involved with having Git at the start of the pipelines. In terms of, like, personally, reviews, it kind of very much context dependent, depends on the team, whether that works well for them or not. But yeah, you can see what the other panelists think and any other practices they can think of.
Yeah, I can add something. So if you don't know, I've been, one of my gigs was with John, and there was some tasks that we paired programmed on it. So basically we didn't need any review, and we used the same techniques that we use on software development sometimes. So basically in some tasks we paired, on other tasks we kicked off the story to align our ideas. So we basically use the same techniques that we use on the traditional software development. It's my perspective.
I completely agree with what Paul said, and as we said in the talk, your context is important. Do what works for you. What I would say though is do read the Accelerate and the State of DevOps reports, especially the 4 key metrics. They're extremely interesting reports, and they balance, a lot of the research they've done is around IT performance. And there's some very counterintuitive findings in there around and reviews and change control and all that kind of stuff is in there. But it's, yes, I personally am a fan of pairing, and even I'm not a fan of, for example, pull requests. But that's just my, that's worked for me well in the past. It very much depends on what works for your team.
Great, thanks, John. And I just want to add into that, or we?
I think regarding versioning, I think one of the things that is imperative is, I think more so than having discrete versions or having, you know, religious debates about which versioning scheme you're going to adopt, I think it's important that the spirit of it be observed, as in if you're promoting the same thing across environments, that's really what matters, as opposed to having drift across what you're promoting across environments. I think that can be a challenge.
Great. Your comment reminded me of experience John and I shared at one particular client where infrastructure as code was being used, but it wasn't being used consistently. So some infrastructure changes were being made using IOC, and other changes were being made manually. And I think that consistency is really important. So making sure you're trying to use infrastructure as code for any change you're making to your infrastructure, and also pay attention to differences between your configuration and then the actual kind of scripts as well, because the Accelerate book talks about this as well, that teams that are very, very effective in their IT delivery, they have pretty much everything that defines their environments, their infrastructure under source control and contributing into an automated pipeline for deploying their infrastructure. If you just have a bit of it, like the Terraform themes or the scripts, without the configuration parameters, then that can leave you in still a kind of difficult place. Okay, should we move on to the next question? Right, let's click on this done. So the next question is, any practical tips for blue-green deployments in Terraform?
That's a large topic. It very much depends what you're doing. Typical consultant answer, it depends. I'm sorry about that. I would just say, generally. Again, it's all around making sure that you've put in whatever you need to put in to reduce mean time to recovery. So just think about how you could do that, what that involves. But it very much depends on what you're deploying, whether it's load balancers, EC2 instances. I'm afraid that's the best I can do.
I think I'll add to what John said. I generally tend to find Terraform a somewhat blunt instrument for doing nuanced state change. I think with great parallelism comes great absence of control, and so because you're having it converge to a state that you've predefined, or to obscure the term declarative that you've declared. Terraform sort of tends to get there. When things don't go as planned, sadly, the difficulty with Terraform is it just says, oh well, I'm kind of done. Go with God or whatever deity or not lack thereof that you believe in to clean up now. So that's definitely a limitation, and you might want something that's slightly more focused, not quite as blunt to do your blue-green deploys, particularly the crucial switch over bit.
Do you have any suggestions on what might be more focused, Ali? I'm going to put you on the spot. I'm trying to think examples as well.
Well, it's a good. Ali's point is very good. So I think you need to kind of like work backwards and work out why you want what is it you want to do. So progressive delivery which is kind of what blue-green is a form of, is becoming more and more popular. So for example, I've worked in engagements where we've done it by geographical region, because it just so happened that some parts of the world use a particular thing slightly less than other parts. And in that case, we used the content delivery network we had a CDN in front of our system. We used geolocation to slowly start swapping people over to a new system, for example. So that's, for example, might be one slightly nicer way of doing it.
Great. Okay, I hope that's helped answer your question, Andrew. Let's move on to the next one. So this is one from the panel themselves. What do you find challenging about infrastructure tooling, having come from development and used developer tool sets? I think this was one that Duarte suggested, given his background as a developer, journeying towards being a platform engineer.
Yeah. So infrastructure tooling, having come from development, obviously bash scripts is it's an issue for us. I'm not happy to do it, but more about the tools, I don't see an issue. I just see an issue in terms of the approach that we took when we start to build things, and feedback loop is the key. Issues with the tools, I don't see any problem with that. Are you thinking about a specific issue or a specific problem?
I think the question is just generally what, from my experience, trying to change where I've been used to, writing software and using TDD and getting their fast feedback, and being able to commit stuff, see it deployed, and see it change very quickly. I think I've had to get used to the like the slow feedback and the differences of tools. But I think this question is getting, is there any other challenges that you've found in kind of switching over from being more dev focused to being more infrastructure focused?
I can suggest a couple of things that I've come across over the years. So sometimes the tools don't really do what they say they're going to do. So I remember getting caught up by Terraform saying you can mark a resource as do not destroy or something like that. That doesn't mean don't destroy it. Not under all circumstances. And yeah, that hurt when that happened. Rolling back, CloudFormation rolls back if a change fails at some point, and it's a really good job of that. And Terraform doesn't. So I did CloudFormation first, and then Terraform came to a bit of a shock when everything went a bit wrong once. And I think the really big challenge is just how they manage state. So again, CloudFormation manages state internally within AWS. It's all taken care of behind the scenes, whereas Terraform doesn't. You have to decide what your state management approach is going to be. You're going to have one state file, multiple state files, where you're going to put it, you're going to version it, and so forth. So I think, as John mentioned earlier on, it's like a really rapidly evolving area, and I think there's lots of kind of pitfalls at the moment, more than I would expect with normal programming language, and particularly that living with that state living out there, that you don't really get that so much with programming normally.
And one issue that I faced recently was because AWS is evolving on the certain speed, and Terraform is moving much slower in the compatibility with AWS. We faced an issue where certain resource on AWS supports certain features, and it's not possible to declare those features with Terraform. So our solution was to declare a CloudFormation stack inside of Terraform, because CloudFormation is evolving more fast because it depends on AWS. And yeah, this is the issue that we faced recently.
One area that I think definitely could do with a bit more love is all around composability and packaging. So Terraform modules kind of works, kind of doesn't, but just making things more reusable, especially when you start wanting to roll it out to development teams, I think that at the moment has got quite a few rough edges.
So this might be I guess maybe stretching the definition of infrastructure as code, but as people get into things like Lambdas and serverless execution environments, I think the line between infrastructure and code gets even further blended. And I think to John's point about packaging, everyone has a non-standard way. You can't just package a thing in many languages the way you would, particularly dynamic languages, the way you would using the package management that's available for that language. Similarly, permissions for execution, they're becoming fiendishly granular, and the tooling in which you build your Lambda is different from the tooling in which you deploy your Lambda. It's different from the tooling where you declare the permissions for your Lambda. So you need to know all of those things. And then the test framework you use to write your Lambda is different from the test framework that you use to test your infrastructure, is different from the absence of test framework that you use to test your permissions. So all of those things, I think these are sort of many here be dragon situation, because this is very nascent. And so I think rather than just make criticism, I think that it sort of really brings forth sort of the, DevOps is an approach and not a job title, right? Like, talk to people, they might have the paper cuts and you might benefit from that. Don't just struggle in silence.
Great, there's some really good answers there. Okay, let's move on to the next question from Martin Warnett. How do you balance testing the configuration for the infrastructure and avoiding re-engineering wheel by over-testing the external infrastructure tools? By overly testing the external infrastructure tools, does that mean avoid testing Terraform and Helm themselves?
I think so.
Martin, if you can expand on your question, maybe. Does anyone on the panel have a handle on what Martin's getting at?
Well, I think it's generally a good idea. You shouldn't test what you don't own. And so generally speaking, a good test should be almost like at the acceptance level, certainly for infrastructure. So for example, an example we didn't put in there, but we did some testing for Duarte and myself. We were working on a Lambda to basically copy log entries from CloudWatch logs into Elasticsearch. So the test we did was just simply, and that was all provisioned using Terraform and the serverless framework. So the test we had was simply, we didn't test any of that as such. We just basically would fire in a log line into CloudWatch logs and then would keep on checking Elasticsearch to make sure that it appeared. So it's at that kind of level. It's basically saying, what do we want to see to happen? And And that's when you can start using it for synthetic testing as well, or synthetic monitoring. So I think that's the spirit of the question, I think. I'm not sure though.
Okay, anyone else want to add to that, or should we move on?
I guess I could just say you can't really avoid testing the infrastructure when you get to that deploy phase, right? You have to. All the examples that John gave were really good. Actually, I was taking some of those, doing some of those. But once you've tested your manifests and things like that, really, it becomes real when all the actual infrastructure applies. And I guess you can't really. I don't have any way around that. But yeah, it's a good thing to think about. Make sure you're not testing things that you don't need to, you don't own.
Okay, great. Thanks. Martin's clarified the question. I think the responses have covered that. Cool. Okay, then we'll move on to a question that often comes up. Are there best practices for incorporating infrastructure as code and ITIL change management?
Well, I think the infrastructure as code really supports the ITIL style change management, because it does kind of mean that you describe what you're going to do before you do it. You can capture that in change records, and then you know when it applies, it's exactly what you said. There's nobody logging onto SSH and running commands and things like that. So I've not come across any issues actually so far where there has been like an ITIL style change management approach. That's the person asking the question. If they have a specific example, that'd be really helpful.
Yeah, if the person asking the question, if they can expand on it, that'd be useful. I'd kind of back up what Paul has said, that when you're applying the kind of practices that John's described and you're consistent in applying them, then it makes it even easier to track changes or control changes that are going into all of your environments, and especially your production one. Infrastructure as code has been a great enhancement in the level of traceability and the level of granularity that we now have over changes that are being made to the lowest level of our infrastructure.
It would be kind of amazing if things like configuration. I've not really done anything deep in ITIL for a few years, but I remember change management databases and configuration items and things like that. It would be amazing if they were kind of like integrated with these sort of IAC tools, so that your change record would automatically know exactly what was being changed and things like that. But that's pretty much a pipe dream at this point, as far as I know.
There's some clarification. I found ITIL is slow process where IIC is fast. So I'd definitely go and read Accelerating the State of DevOps. That should, or then maybe print off the report and give it to your sponsors, because there's some stuff in there that might cause some rethinking around change control. There's some very interesting findings there. That generally works quite well to try and maybe talk around what you can do about that. There's some very interesting findings backed up by evidence, which might help address that issue.
We had a long journey at one client in helping them move away from having change control boards for every change that was being made to production, because that was really hampering our move to continuous delivery. And it got stuck for about, I think, 2 or 3 years, where engineers could make changes into any environment apart from production, and that final production change had to be done by a single operations team, where they basically had an air gap where they had to take a USB stick and cross the air gap with it. But 2 years of persistent discussions and trying to understand the concerns and showing that the traceability that the combination of things like Jira, GitHub, and modern practices give you generally address the concerns that ITIL and change assurance boards are trying to address. So it is possible. Sometimes it can take a long time in other places. Okay, should we move on to another question? Right, Andrew Leeming had a question. For testing Terraform, am I constrained to having to know Go, TerraTest, or Ruby? What if I do not know either language?
No, you're absolutely not. So as I mentioned early on, the tools and the approaches we used aren't specific to the particular tools. So for example, when TerraTest, what that was doing underneath the hood it simply was just invoking Helm and Terraform. So it was just using an os.process call, and then it was just basically capturing standard output and then parsing that. So you get that out of the box with that particular library, but you can do that with any particular language. There really is nothing there that's tied into those particular tools. And the source code for TerraTest is there, so Go's fairly readable. You could have a look and replicate what they do in the language of your choice.
I had a quick Google while you're doing your talk, John, and I found there was, for example, like the PyTest module, which purports to they kind of a Terraform test plugin for Python as well. So if you know any language, there's a fair chance you'll find something that can help make your life a bit easier in testing infrastructure code in that language, I would imagine.
I'll go against the grain slightly here. So in some way, I think if you're going to need to build lots of scaffolding in some cases, I think it's worth maybe taking on the overhead of using an existing toolkit, because debugging and validating your test harnesses, your test scaffolding is I've learned the hard way, quite non-trivial. So the less code you have to maintain, the happier you generally be. So having to build the test scaffolding and then write the tests, or enhance the test scaffolding and then write the tests, sometimes isn't worth it. And a lot of these testing frameworks can almost be treated as DSLs, where you don't necessarily need to expose yourselves to the full onslaught of all of the syntax of the language that they're written in.
Great. Okay, thanks for those. We'll just cover one more question, if possible, before we close at 7. So Andrew's other question is, any opinions on alternative challenger IC tools like Pulumi, which I've never heard of? So anyone on the panel want to cover that one?
We have a colleague who's really bullish on it. It's finally getting to the point where it's the promise of potentially type safe infrastructure, sort of actually being able to see if things compose, to John's point, is possible. It's early days, but it's promising, is sort of the weasel answer.
And absolutely, as Ali's saying, using Pulumi, which is basically allowing you to write infrastructure using languages like Java, Go, Python, whatever. The nice thing about that, one of the side effects is all that packaging problem, i.e. How do you modularize and share your infrastructure's code? You get that for free, because that problem's already been sorted out. So whether it's a jar, whether it's a pip package, which is really quite something.
Great, excellent. Thanks for covering that. Okay, we're at 7 o'clock, so let's draw it to a close there, because I know people have kind of lives to get on with. Thank you very much to the panel. So thanks, John, for presenting, and for Duarte, Paul, and Ali contributing to a really useful discussion. I've learned a lot myself about infrastructure as code. Next week, our summer series is going to move on to the gnarly topic of having to choose, or how do you choose between refactoring or rewriting code. Julia Wonchers, one of our technical principals in the US, will be talking us through the wider implications of this decision and how taking a strategic approach can help. You feel free to sign up for this talk now. The details of it are on equalexperts.com. Thanks again for joining us this evening. I hope you found it useful, and maybe see you next time. Thanks, folks. Bye.